Hello everyone. Hey there. Welcome back. This is part 4 and this is the last part that we're going to cover in thermochemistry. And in this part we're going to look at constant pressure calorimetry, otherwise known as the coffee cup calorimeter. So constant pressure calorimetry we can use to figure out the heat capacity of an object or the specific heat of a substance. So if we were to put a hot piece of metal into the water and we could measure the change in temperature to see what heat was transferred from the hot object to the water. So we need to know what the beginning temperatures are of each one of those, the water solution and the metal. And in this case, the metal object is the system and the water is the surroundings. Okay, and so this is really what it looks like. You have your, get my pen ready. I like purple. You have just a coffee cup. A lot of times we'll nest them and have 2 in there. We have water. We have a thermometer. We might have like this stir thing in there to make sure that we can make the reaction go as quickly as possible. And then we're going to look at what the beginning and the ending temperature is, and then that'll give us our delta T. All right, we'll know, and for the case of this particular type of calorimeter, once we calculate the heat of the system, okay, the heat of the system, since like whatever goes up must come down in the law of conservation of energy, the negative of that number is the Q of the surroundings, or the heat of the surroundings. And so then we can do various calculations using that. We're just going to do some simple calorimetry calculations for the purposes of this course. So you put a metal pellet with a mass of 100 grams, originally at 88.4 degrees C, and drop it into 125 grams of water, which was originally at 25.1 degrees C. The final temperature of both of them when they come to what we call equilibrium, okay, when it stops, the temperature stops moving back and forth, is 31.3 degrees C, and it wants us to calculate the heat capacity C in joules per degree C of the pellet. So we're going to use Q equals SM delta T to determine the heat absorbed by the water, and then we use Q equals C delta T to determine the heat capacity of the metal pellet. All right, so let me look over here because I had this written down so I won't forget what my numbers are. All right, so I didn't have enough room on that other page. So the mass of the pellet is 100 grams. The mass of the water is 125 grams. The delta T of the water is going to be 31.3. Sorry, I'm looking to see what my dog's up to. Minus 25.1, otherwise known as 6.2 degrees C. The specific heat of the water, as we know by now, is 4.184 joules over gram degree C. And then the delta T of the pellet is going to be 31.3 minus 88.4. So its final is lower than the initial because its temperature is going down. So my T sub F and T sub I makes this a negative number, so minus 57.1 degrees C. So the equations that we're going to use are Q equals MC delta T, and that's for the water. And then the Q of the pellet is C delta T. Okay, so the C of the pellet, if I rearrange that, is equal to the Q of the pellet divided by delta T. Why did I do that? Because that's what I'm looking for, is the C of the pellet, right? I am finding the heat capacity in joules over degrees C of the pellet. Okay, so the first thing I'm going to do is I'm going to use this. So Q is equal to the mass, which is 125 grams, and this is water. All right, times 4.184 joules, our old buddy, times gram degrees C, times delta T, which we said was 6.2 degrees C for the water. So when I do my calculation there, I'm going to get 3,242.6 joules, and I'm just going to leave all of those decimal places there for now. Then I'm going to use that number, okay, to find the C of the pellet, because, as I said, the Q of the water is going to be, because that's our surroundings, is going to be equal to the negative Q of the system, which in this case is the pellet. All right, so the Q of my pellet is going to be a negative 3,242.6 joules. Then the C of the pellet is going to be equal to, we said, Q of the pellet over delta T of the pellet. So that's negative 3242.6 joules divided by a negative 57.1 degrees C. And that simple math, since those are both negatives, they become positive. 56.8 joules over degrees C. Okay, and so that is the heat capacity of the pellet. So it will take 56.8 joules for every increase in degrees C. Okay, so that's a typical calorimetry. So and you'll have that formula on your formula sheet. For practice on this one, I've given you a kind of a tricky one, okay? I just want to give you a little heads up on it because you're trying to find the final temperature, all right? And so you're going to have to do some algebra things to this, okay? Because remember, this is Q equals MC delta T, and this delta T equals TF minus TI. Also remember that you've already, it's saying from up there you've got a mass of 218 grams, but your initial temperature here, that's T sub I for your water. Your T sub I of your pellet is 95. And then the C of the pellet we calculated in the previous problem, which was 56.8 joules per degree C. And the mass of the pellet, because it says you're going to use the stuff from problem 5.5, which is the one previous to this. So your mass was 100 grams, all right? So you're going to have to work with this a little bit and make sure you're doing the algebra correctly. But that's the only tricky part to this. Otherwise, you're using the same technique as you did before. All right. Have fun with it. Not probably going to ask one of these on the exam, but you should go ahead and work it so that you can know you can do the algebra. And I may have one on the homework. Who knows? All right. So I'll see you when we move on to chapter 6.